All right. So we're now doing in the sequences homework. I want to do a walkthrough for 31 through 35 because they're word problems and they're going to require applications to standard problems. All right. So it says the fifth and the ninth terms of an arithmetic sequence are -9 and -25. Find the first term and the recursive rule for the nth term. So right away, what is the fifth term? -9, right? And the ninth term is -25. So that leaves the sixth term, the seventh term, and the eighth term. And first we need to find the common difference, and to find the common difference, common difference is D, right? So D should be equal to -25. So what I do is I just do -25 minus -9 over -25 is over 9 minus 5. So I'm finding the average rate of change in between -25 and -9 and 9 and 5. So this is going to be -25 minus -9. It's the same thing as +9. That's going to be equal to -16. 9 minus 5 is 4 over 4, which is going to simplify to -4. So D equals -4. And remember, D is the rate of change between each consecutive number in the sequence. So now, if we know that D is -4, that means that each consecutive term is going to be 4 less than the previous term. So -9 minus 4, -13. What's the seventh term? Yeah. Santa Claus?
Yeah.
All right. Yep. So what's the seventh term if the sixth term is -13? So incorrect. What's -13 minus 4?
Thank you.
What's -13 minus 4? There we go. -21, -25. Which means we can add 4 if we're going backwards. The fourth term is -5. The third term, -5 plus 4, -1. The second term, -1 plus 4 is 3, which means the first term is 7. So we know that we can find a recursive rule. So recursive rule requires us to know the first term. A1 is equal to 7. Our recursive rule is going to be AN is equal to does anybody have a guess on what this would be? Remember, it's going to be in terms of the previous term. So any term is going to be equal to the previous term multiplied or divided by what? Plus or minus what? Each term, AN, is going to be equal to the previous term minus what? Plus what? If D is -4, what would each term would be equal to the previous term plus or minus what? What would that be? So, remember, 2, the second term, is 4 less than the first term. The third term is 4 less than the second term. The fourth term is 4 less than the third term. So we're talking about any term, if any term an is going to be equal to an minus 1 plus or minus what? What would that be? Is it an minus 1 plus 2? an minus 1 times 4? Minus 4, very good. All this is saying is that each term is equal to the previous term minus 4. The second term is equal to the first term minus 4, because 3 is equal to 7 minus 4. The fifth term is equal to the fourth term minus 4, because negative 5 minus 4 is negative 9. All right, so that's 31. Hopefully this walkthrough will help you guys out. Problem 32. The second and eighth terms of a geometric sequence are 6 and 384 respectively. Find the first term, the common ratio, and an explicit rule for the nth term. All right? So, I'm going to... Yeah, I can do it with the current screen. So I'm going to have the second term is 6, and then I have the eighth term is 384. And what is the property of a geometric function for each additional term in the sequence? For a geometric function, what are you doing to each additional term in the sequence? Are you adding something? Are you multiplying something? What do you do for each additional term in the geometric sequence? Do you add? Do you subtract? Do you multiply? Do you divide? What is the property of a geometric sequence? What are you doing to each additional term in the sequence? So are you adding? Are you subtracting? Are you multiplying? Are you dividing? What happens to each consecutive term of a geometric sequence? So arithmetic sequences, you are adding or subtracting for each consecutive term like we did in problem 31. We have a common difference. But 32 is a geometric sequence, which means you are multiplying or dividing for each consecutive term. So what are you doing to each consecutive term in a geometric sequence? Multiplying, all right? And R, the common ratio, all right, is what you multiply to get to each consecutive term. So if the second term is 6, the third term is 6 times R. Because you have to multiply by R to get the next term in the geometric sequence. And what we're going to do is going to keep R as a variable, and then we're ultimately going to solve for it. If the third term is 6 times R, and the fourth term is the third term times R, then the fourth term is 6 times R, which is equal to 6R squared. Alright, so if the fourth term is 6R squared, by the same logic, the fifth term is 6R cubed. If the fifth term is 6R cubed, then the sixth term is 6R to the fourth. If the sixth term is 6R to the fourth, the seventh term is 6R to the fifth. By the same logic, if the seventh term is 6R to the fifth, that means the eighth term is 6R to the sixth. And what is the eighth term? It's just given to us. What is the eighth term? 384. So that means 6R to the sixth power equals 384. how would we solve for r? If we had r as a variable, how could we get r by itself? What would our first step be? Would we add by 2, divide by 6? Divide by 6, right? We divide each side by 6. So you have r to the 6th power is equal to 384 divided by 6. Now what is 384 divided by 6? 64. You could take the 6th root of each side. What is the 6th root of 64? 2. Right? So r is equal to 2. So that means for each term in the sequence, you are multiplying by 2. Because if you think about it, 2 times 2 is 4, times 2 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, which is 6 2s. So the third term would be 12, 24, 48, 96. 96 times 2 is 96 times 2 is 192. I'm 384. So you're just multiplying by 2. You go from the second term to the third term to the fourth term, the fourth term to the fifth term. All right. So if you're multiplying by 2 going forward, that means you divide by 2 going backwards. So if the 6 is the second term, then the first term, a1, is equal to 3. All right? And if a1 is equal to 3 and r is equal to 2, in any geometric sequence, an, any term in the sequence, is equal to the first term, a1, times r to the n minus 1 power, which means that an is equal to 3 times 2 to the n minus 1 power. So that's the explicit form of a sequence. A1 is the first term, r is the common ratio. So for example, you could use this explicit rule to find any term in the sequence. If you wanted to have 564th term, you would have 3 times 2 to the 563rd power. All right. Does anybody have any questions about 31 or 32? No? Okay. Am I good to clear annotations? All right. The first row in section G of a baseball stadium has 5 seats. All right. There are a total of 20 rows of seats in the section. If each row contains 2 more seats than the row preceding it, how many total seats are in section G? All right. So there's 2 ways to solve this. You can do this the brute force method. And the brute force method is just starting with 5, right? Each seat has 2 more than it, so 5 plus 7 plus 9, going all the way from A1 through A20. So we can actually do this relatively, if we only have 20 terms, we can do this in our calculator at least decently quickly. You can do 5, first term, plus 7, second term, plus 9, third term, plus 11, fourth term, plus 13, fourth term, plus 15, 6th term plus 17, 7th term plus 19, 8th term plus 21, 9th term plus 23, 10th term plus 25, 11th term plus 27, 12th term plus 29, 13th term plus 31, 14th term plus 33, 15th term plus 35, 16th term plus 37, 17th term plus 39, 18th term plus 41, 19th term plus 43, 20th term, and that will give you the answer of 480 seats, which is the correct answer. So you can do that all in your calculator and get 480. But that process that we did, and this is going to lead up to our summation, can be simplified by a formula, all right? And that formula could be, for at least this specific situation, the number of rows divided by 2 times seats in the first row. So seats in first row plus seats in the last row. And this formula would be much more helpful if, let's say, we had to find how many seats were in total and 300 rows. It would be very hard to brute force 300 rows of seats like this. So in this case, there are 20 rows, 5 seats in the first row, 43 seats in the last row. So we would have 20 divided by 2 times 5 plus 43. So that would be equal to 10 times 48, which is also equal to 480. And hopefully they will see that both methods get our total number of seats in the row correct. All right. Are there any questions about? Is there any questions about this problem? How we got 43 for the 20th row? Any? No questions? 43. Okay. So when I brute force, remember I brute force, I just added 2 till I got to the 20th term, and that was 43. Because in this case, that was the 20th term. But what we could also do is that when we have the first term and the common difference, you can find A20. So we could use our rule for an explicit rule to find A20. So AN, all right, and actually, you can use, on your pre-calculus formula sheet that you get in the final exam, you will get some explicit formulas. So AN is equal to A1 plus N minus 1D. So in this specific case, if AN is equal to A1 plus N minus 1 times D, in this case A1 is 5, so A20 would be equal to 5 plus 20 minus 1 times 2, because this is N minus 1 is 20 minus 1, and the common difference is there's 2 additional seats per row. So that's going to be 5 plus 19 times 2. That's equal to 5 plus 19 times 2 would be, Yes. Yes. Bernard. Was that? Yes. 38, right? 19 times 2 is 38. So 5 plus 38 is 43. 5 plus 38 is 43. And so this formula is given straight off of your pre-calculus final exam formula sheet for an arithmetic sequence. And you just plug in the number of seats in the first row for your first term, A1. You know that you're finding the 20th term because that's the number of seats in your last row. So that's 20 minus 1 is 19. 19 times 2 is 38. 38 plus 5 is 43. And remember, this is the seats in the last row that we're calculating. And we also know it's 43 because when we calculated this with brute force, just starting with 5 and adding 2, we got to 43 when we hit the 20th term. But you obviously don't have to do that, all right? So make sure you all are focusing and on task. All right. Am I good to clear annotations? Do you guys need a little bit more time? I'm good? Okay. Find x so that x plus 2, and x plus 3 are consecutive terms of a geometric sequence, okay? And so this requires some abstract thinking, okay? So in our geometric sequence, in their geometric sequence, we're going to have, so x plus 2, and x plus 3 are consecutive terms in a geometric sequence. When you have a geometric sequence, how can you find R, the common ratio? How could you find R, your common ratio in a geometric sequence? Could you? Well, that's for arithmetic, because arithmetic you're multiplying each term, right? But yeah, so you divide one term by the previous term. Because if you think about it, with a geometric sequence, to get to the next term in a geometric sequence, you have to multiply by r. So you have to multiply by r to get from x to x plus 2. And you have to multiply by r to get from x plus 2 to x plus 3. So because of that, if we can say that x times r equals x plus 2, so you don't have to write this down, but just if x times r equals x plus 2, then r is equal to x plus 2 over x. Once again, also if x plus 2 times r equals x plus 3, then x plus 3 over x plus 2 equals r. And so you have the property with any geometric sequence is that you can take one term, divide it by the previous term to get r. So what this means is that x plus 3 over x plus 2 is equal to x plus 2 over x because they're both equal to r. So that's the train of thought you're doing here, where you take each term, you divide it by the previous term to get r. All right? So let's get this. How would we, in this case, if you just have x plus 3 over x plus 2 equals x plus 2 over x, how could we solve for x in this situation? You're given this problem. How would you solve for x? Think back to your math 3 days. X plus 3 divided by x plus 2 equals x plus 2 over x. what steps could I take to solve for x? So how could I start manipulating this equation so I can get x by itself? How could I solve for x? Anyone? Bueller. Alright. You have to cross multiply. You cross multiply, you can have multiply across and then set the two products that you're multiplying across equal to each other. So x times x plus 3 is equal to x plus 2 times x plus 2. So x times x plus 3 becomes x squared plus 3x, which is equal to x squared, x times plus x plus 2, x times 2, plus 2x, plus 2 times x, plus 2x, plus 2 times 2, which is 4. That means x squared plus 3x equals x squared plus 4x plus 4. Subtract x squared from each side. Subtract 3x from each side. And then you have 0 is equal to 4x plus 4, which means that negative 4 is equal to 4x. Oh, sorry. 4x minus 3x is 1x, right? So because, and sorry, so when I subtracted the x squared cancel out. Then when I could subtract 3x, the 3x's cancel out, but 4x minus 3x is x. So I get x plus 4 equals 0, which means negative 4 is equal to x. And I've solved for x, and that's the problem. All right. So please, if you have questions, please ask them so we can break these down step by step. Please make sure you're focusing and dialing in, because it's hard to get this if you're not, you're only applying 60% of your attention to it. Now, so no questions here? Okay. Clearing annotations. $35. A new piece of equipment costs $15,000. Your accountant says the equipment can be depreciated each year by 8% for tax purposes. What value will the company show on the tax return after 5 years? So let's think about it. After 0 years, how much does this piece of equipment cost? $15,000. Right? It's going to depreciate by 8% each year. What can we multiply to make this depreciate by 8%? So when we depreciate by 92%, what decimal are we multiplying it by? Yeah, so 0.92. So if it's $15,000 in the first year, you would multiply by 0.92. So it's $15,000 in year 0. You multiply by 0.92 to get to year 1. Then you multiply by your year 1 value by 0.92 to get to year 2. Then you multiply by 0.92 to get to year 3, year 4, year 5. You also multiply by 0.92 to go from 3 to 4, and 0.92 to go from 4 to 5. So each time you're multiplying by 0.92. All right, I'm hoping this is ringing some bells from our exponential unit. All right, so you could start with, let's say your base value is 15,000, and let's say you multiply 15,000 by 0.92, not just one time, not just 2 times, not just 3 times, not just 4 times, but 5 times. So you do 15,000 by 0.92 to the 5th power. And that's what's going to be the value after 5 years. So $15,000 times 0.92. Oh, sorry. To the 5th power should equal 900. Sorry, not. Oh, sorry. I did 1,500 instead of 15,000, so just move the decimal 1 over. Would it be $9,886.22? So that's going to be, after the 5th year, $9,886.22. So notice there's a big, if you have a good conceptual understanding of exponential growth and decay functions, you actually have a pretty good understanding of geometric sequences. All right. So, and so this could easily be, once again, this could easily be an exponential decay problem. All right. So does anybody have any questions on 35? I mean, anything. Process, getting from the start to the finish. You all good? Okay.